Caffeine. Chances are you've got it right there in the cup you sip every morning, or in that tea you grab in the afternoon, or maybe hidden in a piece of chocolate. Did you know that more than 90% of adults worldwide consume it regularly? That makes it the most widely used psychoactive substance on the planet. And here's the thing. We use it so casually, yet we rarely stop to think about what it really does in our body and why it gives us that spark of energy. Today I'm going to break it down for you. How it works, the positive effects, the downsides, and whether it's addictive. Don't worry, I'm not going to drown you in dry chemistry lessons. I'll explain it like we're sitting in the same room, with metaphors, simple images, and maybe a wink or two. So grab your coffee, get comfortable, because what you're about to learn will change the way you see that drink you love so much. We're going to zoom in from the general to the microscopic, from the taste of a hot cup to the inside of your neurons. By the end, you'll see caffeine in a whole new light. So, let's roll the video and get started. First things first, caffeine is a natural substance found in several plants. It belongs to a group of compounds called methylxanthines. The fun part? This group is known for stimulating the central nervous system. Now, when I say central nervous system, I'm talking about the brain and spinal cord. Think of them as your control tower, running everything in your body. And this, my friend, is where caffeine plays its tricks. So, what do you actually feel when you consume a stimulant like caffeine? Simple, more alertness, more motivation, more let's go vibes. But here's the key question. How exactly does caffeine create this effect? The answer isn't in your tongue or your stomach. It's way deeper, inside your nerve cells. Let's zoom in and explore brain tissue. Picture a neuron. It's a cell with a central body, a nucleus. Imagine it glowing blue at the center, and branches sticking out called dendrites. These dendrites act like antennas, picking up thousands of signals from other neurons. Then there's the axon, a long cable that sends signals away. At the end of the axon are small branches called axon terminals, and at the very tip you find the synaptic button, this tiny bulge where communication with other neurons happens. That's the stage where caffeine steps in. The story begins with an old acquaintance in your brain. Adenosine. Adenosine works like your natural brake system. As your brain spends energy throughout the day, adenosine builds up and attaches to specific receptors on neurons. When it binds, the message is clear. Slow down, you're tired, it's time to rest. That's why adenosine is known as the chemical messenger of sleep. Now here's where caffeine sneaks in. Its structure looks so much like adenosine that it can fool those receptors. Imagine a key fitting into a lock but not turning. It just sits there, blocking the space. That's caffeine. It occupies the receptor but doesn't activate it. The result? Adenosine can't bind, can't hit the brakes, and your neurons keep firing. You feel awake, energized, less fatigued. But here's a subtle truth. Caffeine doesn't actually give you energy. It doesn't replace ATP, the real fuel of your cells. What it does is block the signals telling you to slow down. It tricks you into feeling like you've got more energy. And yet in practice, this can mean sharper memory, better focus, faster reaction times, and even an improved mood, especially on those mornings when you wake up grumpy. Of course, not everyone experiences caffeine the same way. Some people feel it after just 30 milligrams. That's less than a cup of coffee. Others, especially those who drink coffee daily, might need 200 or even 300 milligrams to get the same buzz. That difference comes down to tolerance. When your body is exposed to caffeine regularly, it compensates by producing more adenosine receptors, more locks on the door, basically, which means you need more caffeine keys to block them all, and that's why tolerance builds. Now here's the catch. If one day you skip your usual coffee, all those extra receptors are wide open for adenosine. The effect? A wave of fatigue, difficulty focusing, irritability, and those famous withdrawal headaches. These are classic signs of caffeine withdrawal. Is it an addiction? Not in the same league as nicotine or cocaine, but yes, it does create a degree of dependence. But let's not get dramatic. Science also shows us that caffeine, in moderation, comes with some pretty clear benefits. It sharpens concentration, helps consolidate memories, speeds up reaction times, and can even improve athletic performance. That's right. Elite athletes use caffeine strategically to push endurance and delay fatigue. So what about the downsides? Well, that depends on how much you take. Go too far and caffeine can raise your blood pressure, make your heart beat faster and stronger, and act as a mild diuretic, meaning you'll find yourself visiting the bathroom more often. And if you really overdo it, you might feel jittery, anxious, or even shaky. That's why dosage matters. Up to 400 milligrams a day is generally considered safe for an average adult. But here's the twist. Average doesn't mean you. Everyone's sensitivity is different. For someone new to caffeine, even 30 milligrams can feel intense. For someone used to 2 or 3 cups daily, 200 milligrams might barely register. Another fascinating fact, caffeine isn't just a lifestyle choice, it's also used in medicine. For example, it can enhance the effect of painkillers, especially for headaches or migraines. In fact, some medications actually add caffeine to their formula. Ironically, one of the main withdrawal symptoms of caffeine is, you guessed it, a headache. And here is the part that really blows my mind. Research suggests caffeine may lower the risk of neurodegenerative diseases like Parkinson's and Alzheimer's AS. It's not a cure, and it's not the only factor, but the data points to a protective effect for those who consume caffeine regularly in moderate amounts. Of course, more studies are needed, but still fascinating, right? So, is caffeine good or bad? The truth is, it's not black and white. It doesn't belong to the avoid at all costs category like heavy alcohol or hard drugs. Instead, think of it as a tool. Used wisely, it can help you. Abused, it can hurt you. That's the balance. Some people take a clever approach. They only drink caffeine on specific days, like when they need to study hard or power through a busy workload. That way, they avoid building tolerance but still get the full kick when they need it most. Athletes, as I mentioned, time it for training or competition. It's all about strategy. But here's the most important point, and I want you to take this with you. It's not about demonizing coffee or putting it on a pedestal. It's about knowing what it does in your body. Knowing when it helps, when it doesn't, and how much is too much. That knowledge is what lets you make smart choices. So next time you pour yourself a cup, remember, it's not just a cozy ritual. It's a biochemical trick, blocking fatigue signals, keeping your neurons firing, and giving you that sense of being wide awake. Like any trick, it's powerful when you know how to use it. Thank you for sticking with me on this journey inside your brain and your coffee cup. If you enjoyed this, don't forget to subscribe to the channel and hit the bell so you don't miss future weekly videos. Remember, Knowledge is power, especially when it comes to medicine and anatomy. I'll leave you with this thought. Sometimes the things we love most are the very things worth understanding the deepest. See you in the next video. Take care of your mind. Take care of your body. Blessings.